Hello everyone, this is Shudhanshu Sarkar, Assistant Professor, Narula Institute of Technology, Department of Electrical Engineering. Today I'm going to talk on a topic of electrical circuit and network. So, in electrical circuit and network, this module is this one. So here I'm going to complete or I'm going to give you lecture on this three module, Unit 2, Unit 3 and Unit 4. Within this three unit, in Unit 2, if you follow, you will find in 2.3 parallel AC circuits, RLRC and RLC circuit. So today I'm going to talk on parallel RC circuit. So this will be our topic and this is the lesson plan for this particular topic. And today's topic of discussion is parallel RC circuit. Now, let me start with the main topic. The condition that exist in RC parallel circuits and the method used for solving them are quite similar to those used for RL parallel circuit. So my last lecture was RL parallel circuit. So here the conditions and the other mathematical calculations are quite similar for RL to those used for RL parallel circuit. The voltage is the same value across the parallel branch and provides the basis for expressing any phase differences. The principal difference is one of the phase relationship. So here the main difference between these two, parallel RC circuit and RL circuit, the main difference is the phase relationship. If you follow very carefully, if you think it, then you will, if you learn it, then you will find there is some principal differences and the differences in between the phase relationship. So that's all. This is the basic difference between the parallel RC and RL circuit, but the maximum other calculation is quite similar. So here, in a pure capacitor, the current leads the voltage by 90 degree. We all know this from the phasor diagram calculation that for pure capacitor, the current lead the voltage. So what leads? The current lead the voltage. Current lead the voltage by how many degree? 90 degree. For capacitor, current lead the voltage, but for inductor, voltage lead the current. That means the current lags behind the voltage. So it is capacitive circuit. So here obviously the current will lead voltage by 90 degrees. While in a pure inductor, the current lags. Also written here the voltage by 90 degrees. So this concept is very important. Please remember this. For pure capacitive circuit, what is the relation between voltage and current? For pure inductor, what is the relation between voltage and current? So the relation between these two is very important to calculate the circuit, to realize about the electrical system. Maybe the transmission distribution system, or sometime it may be the operation of different types of motor, generator, alternator. So the concept is very important, whether it is lagging, whether it is leading power factor, lagging power factor. So everything is depending on whether this circuit is capacitive or inductive on this. So just remember, for purely capacitive, current leads voltage by 90 degree. For pure inductor, the current lags the voltage by 90 degree. So this is the basic concepts. Now look, the circuit is given here, the fundamental circuit. So here in this circuit, first a voltage source, ET, AC voltage source. So within a circle there is a sinusoidal symbol. That means it's a AC voltage source. So AC voltage source is given. Then a resistance. In real resistance, it looks like this one, and the symbol of the resistance is this. Now this is the capacitor. and the symbol of the capacitor is like EC is the voltage drop across the capacitor. ER is the voltage drop across the resistor. And here the main current which is flowing from the voltage source, from the source, the main current is IT current. Here we consider the main current is IT current. Now this IT current, look, this IT current is dividing from this node into two different way. One current is IC current that will flow through the capacitor. Another current that will flow through the resistor, that is IR current. Okay, so current is flowing through the resistor. That means I is the current and R through the resistor. I is the current and C through the capacitor. So IC and R, IR. Now the voltage across the resistor, we consider it is ER. Is the voltage that is induced EMF, we can say, and the voltage across the capacitor is EC. Fine, this is EC, voltage across the capacitor. Now here we already talk about the relation between capacitive current and the circuit voltage. We know that current leads 90 degree for a purely capacitive circuit. So here this is the phasor diagram. If you follow, you can find that the current along the y-axis, the current is there, the capacitive current. Along the x-axis, this is the voltage, circuit voltage. So here the current is actually leading at an angle 90 degree from the voltage. So this is figure number 1. So here in this figure, the basic circuit and the basic phasor diagram of a capacitive circuit is given. So the next part of the circuit is here a circuit is given. So the reference vector is labeled E and represents the voltage in the circuit. So here E is representing the voltage in the circuit now, which is common to all elements. Since the current through the resistor is in phase with the voltage across it, IR is shown superimposed on the voltage vector. So here in this given circuit, if you follow, you will find what are the parameters you will be able to understand. Look here, I already explained the circuit. So here the voltage source is E, then the current value is given IT, the total current, that is 14.4 ampere, and from this node the current is divided into two different branches. One current is going through the resistor, that is IR, that is equals to 8 ampere. Another current is going through the capacitor, that is IC, the value of IC is 12 ampere. Now here we consider that IR, we know that the phasor for purely resistive circuit, the voltage induced EMF, or you can say the voltage of the circuit will be along the x-axis. So here IR, the current through the resistor, and the voltage will be in the same phase for purely resistive circuit. And we know that current, the capacitive current, will always lead at an angle 90 degree. So here it is 90 degree leading. So this position it is 90 degree leading. The capacitive current is leading from the voltage, capacitive current leading from the voltage at an angle 90 degrees. So that one is leading. Now two current is there in this circuit. One is IR and another one is, first one is IR and second one is IC. So the summation of this, the vector sum of IR and IC is equals to Which one? IT. If we consider that the summation of these two current is IT, then we can say that IT is the summation of these two voltage, IR and IC. Okay, so this is the phasor diagram of this given circuit. We can explain, or we can uh, elaborate the phasor diagram in this way. And here the angle, this angle between the total current IT and the current across the resistor, we consider that the value is theta, or you can say the current between the angle between the total current and the voltage is theta. Now the capacitor current IC is 12 ampere. So here it is given the capacitive current IC is 12 ampere. So no doubt on this. Yes, it is 12 ampere. Leads the voltage by 90 degree. No problem. Leading the voltage at an angle 90 degree. So this is here is leading the voltage 90 degree. Now in position in an upward direction, this is upward direction from this position. From here it is upward direction, means so this will be in this direction. This is the upward direction, leading the voltage vector by 90 degree. No problem. So that part is also very neat and clean, and I think all of you are now able to understand that how the phasor diagram developed and how to draw it. What is the meaning of the phasor diagram if we consider it with the circuit, given circuit. The vector addition of IR and IC, look here, IR and IC gives a resultant that represents the total IT or line current. So what is the line current here? The line current is this 14.4. So here the line current 14.4 ampere. So that is the resultant current represent or the line current 14.4 ampere. So using the phasor diagram, we can easily identify the current, the phasor current. If you have the current across the resistor, inductor, we can capacitor, we can easily find the total current, or any two if given, then another one we can easily calculate using this phasor diagram. Now the calculation of the value is very easy. So this is the same circuit is given here. This is the phasor diagram we already draw. Now IT, what is IT? IT is the total current. This is IT, and using Pythagoras we can easily find the value that what is IT. IT is equals to root over, that means the basic formula is IT square equals to IR square plus IC square. Okay, so then we can easily write this line IT equals to root over IR square plus IC square. That we know the value. We know that the value of IR is 8 and the value of IC is 12. So it is 8 square plus 12 square, that is equals to root over, if we sum 8 into 8, 8 square 64 and 12 square 144. So 144 plus 64, that means it is 208, and after the root over of 208 equals to 14.4 ampere. So in this way we can find the resultant current of the circuit, or the total current of the circuit. Now using this method we can also find the angle, that is the theta. The angle theta represents the phase between the applied line voltage and current. So here the line voltage is given E. We know that the line voltage is this one and the line current this one. So we consider the angle between the line voltage and line current. The angle theta represents the phase between the applied line voltage and current. So here the voltage is theta, the angle is theta. So we can easily find the angle between the line, that is IT, and I and E, that is the line voltage and the current. Now in this slide it is clearly written that in a parallel RC circuit, the line current leads the applied voltage. Yes, the line current is obviously leading the applied voltage by some phase angle less than 90 degree, but greater than 0 degree. Okay, because for purely capacitive circuit, the angle is 90 degree, but here it is not purely capacitive circuit, so this should be greater than 0 but less than 90 degree. The exact angle depend on whether the capacitive current or resistive current is greater. If there is more capacitive current, the angle will be closer to 90 degree. Yes, for more capacitive current, this point is very important. This point you have to remember. If there is more capacitive current, the angle will be closer to 90 degree. For more capacitive current, closer to 90 degree. While if purely resist capacitive circuit, then it is 90 degree. So it's depend on the value of the capacitive current. While if the resistive current is greater, the angle is closer to the 0 degree. So it is actually depend on the value of the resistor or capacitor which is connected with the circuit. If it is while or if it is the value is resistive current is greater, then the angle is closer to 0 degree. If it is capacitive current is greater, then the value will be closer to 90 degree. So this part you need to remember. This is the important part for the circuit. Now the value of the phase angle can be calculated from the value of the two branch currents using the following equation. So here theta, the value of the phase angle. What is the value of the phase angle? The value what? The value of the phase angle can be calculated from the value of the two branch current. Okay, using the following equation. So theta equals to tan inverse IC by IR. So using the phasor diagram, if you follow, you will find that the along x-axis the current is IR. Along y-axis the current is IC, and we know that tan equals to length by base. So here the length is IC and the base is IR. So theta equals to tan inverse IC by IR. So everything is coming from the basic knowledge. So please clear your concept about the basic, then nothing is difficult. Now let me explain another problem where we will solve current in parallel RC circuit example. Okay, so a circuit is given here. So the value of all the circuit is, it is clear to you that it is 120 volt and 60 hertz. Normally in Indian standard 50 hertz, but in this case it is 60 hertz. So very careful at the time of calculation of omega. Please concentrate on the given value. If it is 60, put the value 60 for F. If it is nothing is given, you can consider it is 50. But if it is given, so carefully consider the value. Now R is given, that is 10 ohms, and X is 20 ohms. So the problem is for the parallel RC circuit shown in below figure, determine what we have to determine. The first one is we have to determine the current flow through the resistor. Yes, this part. So current flow through the resistor means this current, that will be IR. Next, the current flow through the capacitor. This current we have to calculate. Total line current, that means this current we have to calculate. So all these things we need to calculate in this problem. Current flow through the resistor, current flow through the capacitor, the total current, and then the phase angle between voltage and total current flow. So phase angle between the voltage and total current flow, we know what is this. So that part is also we have to calculate from this problem. Next one is uh, express all currents in polar notation. So it may be x plus jy form or any other form. So we have to convert it to the polar form. And polar form means we have to convert it to the r theta form. So that is the important part. Now use a calculator to convert all currents to the rectangular notation. So now from polar to you have to convert it to rectangular. That part is also in this problem. We need to calculate. Now values are given, everything is given, question is given. So no doubt now we can easily solve it. Now the solution is very easy. You already know that how to solve it because you know that IR equals to what is IR? IR is E by R. IR is the current across the resistor. So you can easily write that IR is the current across the resistor. So IR is nothing but E by R. Ohm's law, simple Ohm's law, that is IR. So that is an E value is given 120 volt and R value is given 10 ohms. So the calculating will find it 12 ampere. Now I see the current across the resistor. So voltage is same for the both cases because all are connected parallelly. So the voltage across the resistor is 120, the voltage across the capacitor is also 120 degree. So 120 and XC is 20. So 120 by 20, that means the value of the IC current which will flow through the capacitor, that is IC, that is 6 ampere. Now IT, we know how to calculate IT. This is IT. So this is IR. This one is IC. IR, IC. That is our IT. I already explained in this lecture that how to find IT. So IT equals to root over IR square plus IC square, that is equals to 12 square. The value is already, we find these two value 12 square plus 6 square. So after calculating we'll get it 13.4 ampere. Now theta is tan inverse IC by IR. That part is also done in the previous slide. So theta equals to tan inverse IC by IR. So which one is IR? Look, this is IR, this is IC. If it is theta, this is base, this is length. So theta equals to tan inverse IC by IR. Okay. So this IC by IR, put the value IC and IR 6 by 12 and theta will be equals to 26.6 degree. So in this way we can find the value of theta also. So it is actually not so tough. Use your basic concept, the concept from class 9, 10, 11, 12. That is sufficient to solve this type of problem. Now we have to find so the IT equals to 13.4. Though we need to convert it to polar form. You all know that how to convert it to polar form. That is 13.4 angle 26.6 degree. IR equals to 12 because there is no angle between IR because I is along x-axis, that is along the voltage. So for that it is 12 angle 0 degree. IC is in the 90 degree. That means IC is 6. So 6 angle 90 degree plus 90 degree because IC is actually leading. IC will lead from, so the IC, that's why it is 6 angle 90 degree. And IT is 13.4 because the angle theta is 26.6. So angle is 26.6 and IT is IT value, the value we find 13.4. So 13.4 angle, this angle 26.6. Now IT equals to 12 plus J6 because IT, we know that IT equals to 12. This is 12 plus J6. Yes, J6. If we, and now we are converting it to the rectangular form. 6 angle 90 degree means J6. You know the conversion. I already explained in some previous lectures that how to convert from polar to rectangular and from rectangular to polar. So here IR equals to 12 plus J0 because no imaginary part with IR, and IC equals to 0 plus J6. So only imaginary part is available with the capacitive current. So just for your understanding, let me say that what is actually, suppose r theta is given, so x equals to r cos theta and y equals to r sin theta. Then simply put the value of x and y here in this equation, x plus j1. So you will get the rectangular form. You will get in this form the value from r theta. So what is actually this r and theta? Look here. So here a point is there. A point, suppose it is P, it is x, y, and the distance from the center to the point is r, and the angle is theta. So if r is given, r and theta is given, so you can easily find this y and x from this r and theta value. Well, as per the trigonometrical formula, you know that y equals to r cos theta, because cos theta equals to plus 9. The concept of plus 9, y by r. Yes, cos theta equals to y by r, and sin theta equals to x by r. Right? So using this concept, we can convert it polar to rectangular form, and rectangular to polar form. You all know this. X equals to r equals to, if rectangular form is given, so r equals to x square plus y square, Pythagoras, like here x square equals to x square plus y, that means r equals to root over x square plus y square, and theta equals to tan inverse by. So this is the method and this is the process. Using this process, we can solve the problem very easily. Rectangular to polar and polar to rectangular. R theta to x plus jy and r theta x plus jy to r theta. So as per the uh, requirement of the question, we have to solve that way. Now, parallel RC circuit impedance. The impedance Z. Impedance is always represented with Z of parallel RC circuit is similar to that of parallel RL circuit and is summarized as follows. That the impedance can be calculated directly from the resistance and capacitive reactance values using the equation Z equals to R xc by root over R square plus x square. Why? How can we find this? Because if you follow, you will find that both the resistance and the capacitance connected parallelly. So parallel connection means here it is R xc. The basics of, if the impedance we consider Z, then we know that if something is connected parallelly, so the equivalent admittance will be equals to summation of these two divide. Yes. So R xc plus Z equals to R xc divided by R square plus x square. So in this way, we can calculate the value of Z, that is R plus xc. In this way, directly we can find the value of the Z from the circuit, because to finding the impedance, we have to short the voltage source. We have to remove the voltage source from the circuit and short the line. You know it from the Thevenin's theorem. Now go to the next slide. So for the next slide, we know that the impedance can be calculated using the Ohm's law. Impedance is Z and the supply. So if the total impedance is Z, which is Z equals to E divided by IT. So E is the total voltage and IT is the total current. So Z is simple. V equals to IR using Ohm's law. What is Ohm's law? V equals to I into R. So here R will be equals to V by I. So in this case, R is Z impedance. So and the voltage is E. So replace Z in case of R. So Z equals to V is E divided by I T. So this is the formula. This formula is written here. So using this formula, we can find the Z also. No problem with this one. Now the impedance of a parallel RC circuit is always less than the resistance or capacitive resistance of the individual branches. So impedance of a parallel RC circuit is always less than the resistance or capacitive reactance of the individual branches. Remember this one also. Next, go to the next problem. In the next problem, impedance in parallel RC circuit example here given. So this problem, the values are given, that is 240 volts, 60 hertz, resistance is 200 ohms, and XC, that is the capacitive reactance, is 100 ohms. So all these values, current flow through the resistors, we have to find IR, then current flow through the capacitor IC, then the line current IT and the impedance Z, phase angle between the voltage and the current flow, and if the current is more resistive or capacitive. Yes, so that part we have to calculate. Look here, the resistance value is greater than the capacitive reactance. So remember this. Now solve the problem. This solution method is very easy and very simple. So here IR equals to E divided by R. So IR equals to E divided by R. You know the problem. IR equals to E divided by R. The voltage across the resistor, put the value 240 by 200 ohm. This is 1.2. Now IC equals to E divided by XC because the voltage source is parallel. So voltage is same for both the cases, divided by 100. So 2.4 the value of IC. Now IT from the phasor diagram, we know that IT equals to root over I square plus IC square. So it will be 2.68, and Z equals to E divided by IT, the total, the induced voltage or total voltage, the source voltage divided by the total current. So 240 by 2.68. That is 2.68. We take it from here, and this is given in the problem. So it is 89.6 ohms, and theta is equals to tan inverse IC by IR. Theta is tan inverse IC by, from the phasor diagram we also know this, and finally the value IC is the height and IR is the base. So theta is equals to tan inverse, and then putting the value will get 63.4. The circuit is more capacitive in nature because the capacitive current is greater than the resistive current. Here the capacitive in nature, it will be capacitive because the capacitive current is 2.4 and the resistive current is 1.2. So which one is greater? 2.4 is greater. So the circuit is more capacitive in nature because the capacitive current is greater than the resistive current. So this is the reason for this part calculation. Now let me move to the next slide. So in the next slide, the reference is given here. So to make this PowerPoint presentation, I take help from this particular website. And thank you everyone for watching this video. For any doubts, you can contact with me, and my suggestion, please go through different types of book. Different types of book are available. Solve the problem more and more. That will be clear your concept more and more. So thank you everyone. Thank you for watching the video.